In this video, we're going to solve some exponential equations. We'll start off with the old technique that we used with the one-to-one property, and then we'll move into solving some exactly in terms of logs. So number 16 is 5 to the x equals 625. So 5 to the x equals 5 to the fourth. X has to be equal to 4. And the next one, 3 to the 1 plus 2x, has to be equal to 243. 243 is 3 times 81. Oh, that's 3 to the 4th, so this has to be 3 to the 5th. 3 to the 1 plus 2x. So 1 plus 2x has to be 5. 2x has to be 4, and x has to be 2. If 3 to the 6 minus 3x is equal to 1 over 27, then 6 minus 3x needs to be equal to negative 3. Since 1 over 27 is 3 to the negative third, we're going to subtract 6 from both sides. Negative 3x is equal to a negative 9. Divide by a negative 3 on both sides, and x is equal to 3. Two to the 5 plus 3x is equal to 1 over 16, which is 2 to the negative 4th. Then 5 plus 3x is equal to negative 4. Subtract 5 from both sides. 3x is equal to a negative 9. And x is equal to a negative 3. 3 times 5 to the 2t minus 1 equals 75. I'm going to divide both sides by 3 to get started. 5 to the 2t minus 1 equals 25. 5 to the 2t minus 1 equals 5 squared. 2t minus 1 equals 2. Add 1 to both sides. 2t is equal to 3. T is equal to 3 halves, or 1.5. Now we're going to go on to a different type of problem that we haven't done before, where we're going to solve the exponential equation, but we're going to do it with logarithms. So e to the 5x equals 3. To get rid of the e, we're going to take the ln of both sides. So 5x is equal to ln of 3. I'm going to divide by 5, or multiply by 1/5. X is equal to 1/5 ln of 3. E to the x plus 7 is equal to 5, and I take the ln of both sides. Then x plus 7 is equal to ln of 5, and x is equal to ln of 5 minus 7. 3 to the 9x is equal to 4.5. And 3 to the 9x is equal to 9 halves. That's what that is. I'm going to use natural logs on both sides to say ln of 3 to the 9x is equal to ln of 9 halves. So this is going to be 9x times ln of 3 is equal to ln of 9 minus ln of 2. ln of 9 is 2 ln of 3 because it's 3 squared. I'm going to divide everything by 9 ln of 3 to get rid of the 9 and the ln of 3. And x is exactly equal to 2 ln of 3 minus ln of 2 divided by 9 ln of 3. (24). 3 to the x plus 8 is equal to 7. because our bases are not the same here and I can't get them to be the same, I'm going to use natural logs on both sides to bring the exponent down. So plus 8 ln of 3 is equal to ln of 7. X ln of 3 plus 8 ln of 3 is equal to ln of 7. X ln of 3 equals ln of 7 minus 8 ln of 3. Divide by ln of 3 on both sides. And x is exactly equal to ln of 7 minus 8 ln of 3 over ln of 3. Last problem in this video, in this set, is 4 to the x plus 4 is equal to 5 to the 2x plus 5. Take the ln of both sides. X plus 4 ln of 4 equals 2x plus 5 ln of 5. So ln of 4 times x plus 4 ln of 4 equals x times 2 ln of 5 plus 5 ln of 5. We're going to get our x terms together. X times ln of 4 minus 2 ln of 5 equals 5 ln of 5 minus 4 ln of 4. Before we go any further, I'm going to change my ln of 4s into ln of 2s. So it's 2 ln 2 minus 2 ln 5 equals 5 ln 5 minus 8 ln 2. X is going to be equal to 5 ln 5 minus 8 ln 2 over 2 ln 2 minus 2 ln 5. If these had all had coefficients that were divisible by 2, I would factor the 2 out of the top and the 2 out of the bottom and cancel it. But 5 is not divisible by 2, so I'm going to leave that alone. As I said previously, I would recommend that you look up the video on the quantitative reasoning topic on my website for compound interest problems because there's way more examples there. I'll go ahead and do these since I have time, since I haven't done any of them. Find out how long it takes for a $3,200 investment to double. So I want that to become $6,400. If the interest rate R is 7%, which is 0.07, and it's compounded monthly, that's 12 times a year, and T is what I don't know, and we want to round to the nearest tenth of a year. So we're going to say that A is 6,400 equals 3,200. 1 plus 0.07 divided by 12 to the 12t is going to be, when I divide by 3,200, this is going to be 2 on this side because it's doubling. And this is going to be 2 is equal to 12.07 over 12, the 12t, like that. And I'm just going to use ln to get the 12t down, because that's what I'm interested in solving for. So ln of 2 is equal to 12t ln of 12.07 divided by 12. So t is equal to ln of 2, so 1/12. So 12 in the denominator here, and there's an ln of 12.07 divided by 12 in the denominator here. We're going to have to use our calculator because it says to round to the nearest tenth of a year. So we need ln of 2 divided by, parentheses for the denominator, 12 ln of 12.07 divided by 12, close the log, close the denominator, and we get 9.9 years. So we're going to have to wait 10 years, roughly, for our money to double. And then the last problem here is the formula A equals 290 e to the 0.03 t. Models the population of a particular city in thousands. Be careful of that, this is in thousands. After t years, when will the population reach 240,000? Or I'm sorry, 420,000. So 420 over here equals 290 e to the 0.03 t. We started off at 290,000. We want to end up at 420,000. So we're going to take 420 divided by 290 is, and then I'm just going to keep these numbers in the calculator. And take the natural log of that. So I get the whole thing. 0.03 t equals 0.03703737883. I'm going to divide that by 0.03. I get that t equals 12.34579294. We weren't told what to round to, but we're going to need more than 12 years. So if we want whole numbers of years, we're going to have to go to 13. So it says years after 1998, right? So we're going to say that we need to be in year 13. So we need to round up to 13, and we need 1998 plus 13. It's going to happen sometime in the year 2011. No. They must have done some rounding here that I didn't do because I used exact numbers all the way throughout. But you should get more than 12 years after 1998. So add 13 to it and you should get 2011. All right. There you go. That's it for this video. And that's it for everything with exponential and logarithm functions. Come back and talk about the last topic in college algebra in our next set of videos, which is going to be systems of equations and matrices. See you then.